Good afternoon, everyone. How's the conference going? Yeah, so far so good. Um, let's begin. My name is Alvaro Sanchez, and I promise you two things. You will learn something new, and you will have fun. So let's try. I'm coming from Madrid, from Spain. I'm a Java developer. Who's a Java developer here? Yes. Who is not a Java developer? What are you guys are using? Oh, okay, yes, it's right. As a side note, like I'm telling you here, I'm working on Java since the beginning of my career. In 20 years ago, I was working for BEA Systems. Who knows? Who remembers that company, BEA Systems, the creators of WebLogic, which was bought by Oracle. And I joined the project for the Euromillion lottery in Lisbon for Santa Casa. And after that, I spent a few other months in a project for Ministerio das Finanças, also in Lisbon. So unfortunately, it was 20 years ago. I forgot all my Portuguese skills, most of them. Today, I'm working on Micronaut at Oracle. The part of Oracle that I'm working for is Oracle Labs. It's a research and development organization of Oracle. And it's the same organization that is working on Grails VM, which you probably know. I don't know if you had the chance to attend to Alina's session, yes, on Grails VM. So she works on the same org. I'm not a developer advocate myself, just a committer on the project. But I enjoy going to conferences like this one. This is my second time in Porto Tech Hub. Also this year I've been to Coimbra for JNation. And yeah, whenever I have a chance, I like to do conference sessions. On a personal note, let me tell you that I'm a runner. Yes, don't be surprised. I'm a runner, and I run a lot. I run applications, containers, and I run them very fast. I was working on Micronaut, so that's enough about me. So, who's using Spring Boot here? Yeah, fair enough. Can you leave the room, please? Thank you very much. Who's using Quarkus? Okay, and who's using Micronaut? You're in the right place because you want to learn something new, which is appropriate. We started Micronaut in the year 2017. Let me tell you a story, which is a true story. When we started Micronaut, to give you a little bit of context, the team creating Micronaut is the same team that created Grails. I don't know if you heard about Grails framework. So we spent over 12 years creating a framework, and we learned quite a few experiences, and we wanted to do something new, something from scratch. Originally, this framework wasn't called Micronaut. The code name was Particle. But we couldn't use Particle because there was a trademark and an existing project domain name was not available, blah, blah, blah. So we had to choose a new name. And we ran a poll internally across the team to choose a new name, and I made a proposal which wasn't selected. I still don't get why. My proposal was to name the framework Summer, because we all know that summer is better than spring. Now that's another joke. Sorry about that. I literally spent 1 year working for VMware. It's a wonderful company. But yeah, let's talk about Micronaut. So slides are on speaker deck, not only this deck, but also a few others in case you're interested. There's a room in the front rows, and there will be some code. I had a shower this morning as well, so should be okay. Who has never heard about Micronaut before? Okay. Yes. So there's three ideas, that I would like you to get out of this presentation about Micronaut. One is that Micronaut is a modern open source Java framework. And by modern, I mean that we started working on it in 2017. If you compare with a traditional Java framework, name Spring or name Jakarta E or whatever you want to use here, those were created many years before, right? Well, Spring Boot is, I think, 2014 or something like that, or 13, but the Spring framework was created in year 2002. If you think of the type of applications that were created in 2002, they were different, quite different than the one that we create today. So it could be possible that we have someone in the audience which was born after Spring. That could be possible. Yeah, we no longer have application servers, and we no longer have ER files or Word files or anything like that. So the world has changed towards microservices, serverless functions, etc. So we wanted to focus on the type of applications that are created today. It's a general purpose framework. You can use it for anything you want. People typically use it for creating REST APIs. That's the most typical use case. But you can create, for example, a Kafka consumer with no HTTP server whatsoever, or a Kafka consumer, which is a separate, or a serverless function and deploy on AWS Lambda, etc. You name it. You can create a command line application as well. So there's multiple use cases. And the third idea is performance. Performance for us is very important. It's kind of an obsession. We work really hard to shave every millisecond that we can from the startup time and every megabyte that we can from the memory consumption. So there's two metrics that we believe that will dramatically change your developer experience. And this is the whole point I'm trying to make in this presentation. Performance is not only about those metrics, right? We have peak throughput and like runtime performance, right? And Micronaut is, let's say, competitive. I recommend you to check there is a kind of famous benchmark in the industry called the Tech and Power benchmark. They compare not only Java framework, but all kinds of things like PHP and Python and whatnot. So you can check the Micronaut numbers there. But the ones that I'm talking about now are startup time and memory consumption. So how do we do that? That's the question. And to answer this question, I want you to reflect on what happens when you use in a traditional Java framework something like, for example, add transactional. Do you know what happens under the covers when you use add transactional in Spring? Right? No? No idea? Let me tell you, many things. A lot of things happen, right? To begin with, they will have to scan your class path to find such annotation, right? Not only add transactional, but also add, like, for example, add REST controller or, I don't know, get mapping, add auto-wired, right? They will scan all the classes and methods in your class path to find such annotations. When they find one, and I'm using the transactional example because is kind of straight to the point. What happens is that they will dynamically, while your application is starting, they will generate a new class, right? They will subclass your class where the transactional is declared. And they will use a technique called dynamic proxy generation to generate bytecode, right? To produce bytecode while your application is starting. So I forgot to mention that to find such annotations, they use reflection. The Java Reflection API is slow, right? It's getting faster on every Java release, but still this is slow API. So what happens is that frameworks that are based on reflection, they tend to use a reflective cache, which is basically a cache in memory not to query over and over again which are the annotations of a class or of a method, etc. Right? So you cache them in memory. So memory consumption will skyrocket without limit, right? The more bins or sources you have in your application, the more memory it will consume at the startup. That's what we call the footprint, right? So how much megabytes does your application consume right from the beginning of the startup, right? And also, the more it will take to start up, the more time it will take. Again, without limit, right? And things will get worse because you probably not only use Spring, but for example, Hibernate. Who's using Hibernate here? Is very popular, right? And Hibernate is very powerful, but it is also heavy using reflection, right? So they also have a separate reflective cache. And they will contribute to the startup time and memory consumption of your application, right? Is there any other way to do this? That's the question, right? That's the question that we wanted to answer. And it turns out if we move a step back, it is year 2006. We have people in the audience that were going to the kindergarten in year 2006, right? Year 2006 is when the JDK introduced a specification called Java Annotation Processing API. The Java Annotation Processing API is a standard Java facility to hook into the compiler. So we hook into Java-C, right? So basically, what the approach we're taking is that we're moving as much as we can from the runtime phase to the compile time phase, right? During compilation, we will visit your sources and we will produce all the framework infrastructure, right? So that at runtime, there's no reflection, there's no proxy generation, there's no dynamic class loading, and we don't scan your class path. Never, ever promise. Which means that at runtime, there's no magic to run, right? Magic has been already generated. We produce the bytecode most of the times, but there are some use cases where we're producing source code. There are pros and cons of every approach, but for you, this is internal, right? So this means that all the framework features that you're used to, like, for example, dependency injection, AOP, like a controller, right, will just work, right? Like I said, Micronaut is a general purpose framework. I saw some people waking up with this slide. You can use it. We have support for plenty of technologies. This will be the hello world. We purposely use an annotation programming model, pretty much like a Spring, like Quarkus, like everyone, right? But in this case in particular, in the case of Micronaut, we purposely choose not to reinvent any terminology. So you know what a controller is. You know what the application context is. You know what a bin is. And we use the same names, right? Because there's no point on calling them differently, right? So it is the same application programming model. And for most of the cases, you can use literally Spring annotations, and this works. And And this works because we have the ability to map from the Spring annotations to the Micronaut annotations during compilation. So this is add controller from Micronaut HTTP package, but you can change it for address controller from Spring MVC, right? And this is add get from Micronaut, but you can use add get mapping from Spring MVC. Or you can replace Spring MVC with JAX-RS, and it will work the same, right? They have this ability. But Micronaut, I like to call it batteries included, because it comes with nicer features, like, for example, a built-in HTTP client, a declarative HTTP client. This is comparable to Spring Cloud OpenFame, if you know that, or Retrofit. It's another library for these games. The idea is to have an HTTP client, but instead of dealing with low-level request and response, etc., you basically use the HTTP annotations of the framework, like in this case, the get, and you use the return types and the parameters to determine where the requests have to be sent to, and which is the payload, which is the response, etc., right? The difference with solutions like Spring Cloud OpenFame is that this client is going to be implemented at compilation. It's an interface, and the implementation class will be generated during compilation. For data access, we have a solution called Micronaut Data. There's a space in the first row, so please come closer. Don't be shy. Micronaut Data is using the repository pattern, pretty much like Spring Data. So if you use the Spring Data, this is going to be quite similar. But again, the difference is that this interface is going to be implemented at compile time. And being a compile time framework is relevant also for your developer experience, because this is, for example, a repository operating over a user entity. And this user entity has supposedly a name attribute. If you were to make a typo, either here, or here, or here, you will get a compilation error, right? Instead of a runtime exception with other framework. You see my point? Yeah? Blink your eyes. Okay, so what else do we have? We have something very nice called test resources. So who's using test containers? Who has no idea of what test containers is? You all know test containers. That's very nice. You don't? Okay. So basically, test containers is a library for using containers for tests. I mean, the name is not very imaginative. The use case is you have an application that needs a database, and typically what we have done in the past is to run with H2 like an in-memory database for your tests, right? So you can test against your database. But for example, if you're using like a random example, for example, Oracle database, you're not gonna and you're writing PL SQL, you're not gonna test PL SQL with H2, right? You need to provision an Oracle instance somehow, right? So Testcontainers is a separate library, open source project that helps you provisioning a database container for your test, right? It's integrated into the unit, Spock, etc., and will manage the lifecycle of a container. Now, we have an integration or an instruction over test containers called test resources. And we call it test resources because it has the ability to provision anything, not only for testing, but also for local development. I will show that later. I will show the whole thing later, actually, during the demo. There's other things that we have. Who is using Jackson here? You're all using it. Even, I mean, if you're using Spring, you're using Jackson. Very likely. Jackson is a Java library for JSON and XML serialization, and this serialization is a wonderful library. Has a million features, but it uses reflection heavily. So we re-implemented Jackson Databind with a compile time and reflection-free approach. It's a drop-in replacement, so you can keep your Jackson annotations in your sources, but not use Jackson Databind at runtime, and instead using Micronaut serialization. And this gives you the ability of having like runtime portability, so you can, for example, move from Jackson annotations, which are like kind of non-standard, to JSON-V, for example, right, or VSON. This is much faster than Jackson. The memory footprint is much smaller. Your jar file will be several times smaller, etc. Right, and it is safer because we perform type checks during compilation instead of at runtime. And also, Jackson is able to basically deserialize by default any object, right? Whereas with Micronaut serialization, you have to be explicit about what can be serialized or deserialized. And the same thing happens with validation. So there is a standard in Java called Beam Validation API. Beam Validation API has a reference implementation called Hibernate Validator. And again, Hibernate Validator is a wonderful library for validation. That's many things, but again, it's using reflection crazily. So we re-implemented most of the spec, basically all the parts of the spec that don't require reflection, and we support it universally across the framework, everywhere, in controllers, entities, configuration classes, you name it, right? And again, this is much faster. It will consume less memory, and will be compile time and reflection free. So how do you get started with Micronaut? We have a guides website, guides Micronaut.io. Guides are like step-by-step tutorials that you can follow to create an application. And they are of different topics, like, for example, sending an email with Micronaut, or creating your first Micronaut application, or deploying a Micronaut application to Oracle Cloud, or to AWS, etc. There are, I don't know, 40, 50, 60 guides, something like that. We have a website generator, or a project generator called Micronaut Launch. This would be similar to Start Spring.io. So Micronaut Launch has multiple frontends, let's say. So this is like the web frontend, but we provide a command line application if you're a terminal person. So if you want to create applications from the terminal, you can do so. If you're using IntelliJ Wizard, or IntelliJ Ultimate, sorry, JetBrains has integration with Micronaut Launch to generate projects. And in the case of Visual Studio Code, Oracle is providing what's called the GraalVM extension pack, which includes support for Micronaut and a few other things. Is anyone using Visual Studio Code here for Java development? Do you like it? Not so much. You do like it? Yeah. I've been using IntelliJ for so long that for me it's hard to move, but this is a good alternative. Few notes on Graal. Who heard about GraalVM before? Yes, probably from Alina's session, or maybe before. Let me tell you that Graal is an umbrella brand for 3 different projects. One is GraalVM, which is what probably you are already aware of. But there's 2 other projects under this umbrella. We have GDK, or Graal Development Kit for Micronaut, and GraalOS. I will talk about the first 2. The third one, GraalOS, is not released yet. It will be a new serverless platform powered by Micronaut and GraalVM, promising the ability to run serverless functions without any container overhead whatsoever. So is anyone deploying on AWS Lambda or any serverless function, right? So in serverless deployment, there is this called the startup problem, where basically the first time you invoke your function, you'll have to pay the price to start your function, right? And there is a footprint of a few hundred milliseconds, which is the internal container startup that Amazon is running under the covers. With GraalOS, there will not be any container startup whatsoever. So you can have a cold startup of a few milliseconds, right? And then this will allow you to scale to 0 and few other options. GDK, let me tell you very quickly, GDK is a downstream distribution of Micronaut. Micronaut is open source, it's Apache 2 license. GDK is also open source, but the binaries of GDK are built by Oracle on Oracle infrastructure. And you will ask why this is relevant, because there are some organizations, some companies, think of the type of customers that Oracle has, like banks, governments, etc., which are unable to use any binary from a public repository, right? They need a vendor that provides binaries which are like security tested and with vulnerability scanning, provenance, and whatnot. So this is exactly what GDK is for. And as part of the GDK, there's not only this redistribution of Micronaut, but there's also a different guides website that you can check on graal.cloud. You will find the same guides as the Micronaut website, but few others specific to Oracle Cloud. What's unique to GDK is the hands-on lab. This is really, really cool. Because guides is basically text with instructions that you follow. But hands-on labs are, you get an integrated environment. You literally get a VM in the cloud. And with all the software installed, and you basically run the commands there to create your application. So it's really cool. And you can run it in the Oracle Cloud free tier. Or if you have your own tenancy, you can do that as well. And one note about GraalVM. Let me tell you, is anyone using GraalVM at the moment? You should use GraalVM. You should GraalVM in your laptop, in your server, everywhere. And you will say you're biased, and I am biased. I agree, but still you should use it, right? Because it's gonna make your Java applications faster just by changing the JDK. Believe me, or don't believe me, but maybe you heard about the 1 billion row challenge on the internet. Yes, this was a challenge on the internet with the idea that you have to parse one text file of 1 billion rows, right, several gigabytes. And the file was like a CSV of some temperature measurings, and you had to produce some average and things like that. So you could create like a solution which would be like really fast, and then people could do like, because it was done on GitHub, people could use your solution and, for example, change the GDK. People did that and changed the default Eclipse mirroring for GraalVM JDK for Java 21, I think it was, or 17. And the same program would run 10% faster with no code changes, right? So that is the left branch. GraalVM is an open JDK distribution. So you can use it for, or instead of Eclipse Submarine, or I don't know, Amazon Corretto, or whatever the JDK that you use. And it's open source, by the way. And you can run your Java applications the same way you're running them today, in JIT mode, right? However, what's unique to GraalVM is that they also allow you to run your applications in AOT mode, ahead of time compilation. And what they do is basically they take a Java application and they compile it to a native executable. A native executable, let me tell you which are the goals. A native executable will start at much faster We can see that later in the demo. We'll use less resources, less memory, and less CPU. It will minimize vulnerability because in the process of generating this binary, this native executable, they will basically start from the main method and they will traverse your source code to all reachable paths, right? Everything that is unreachable will be dropped. Do you know how many unreachable code you are shipping in your applications? It's a lot. It's likely more than 50%. More than 50% of your classes and methods in your class path will never be used, right? So what GraalVM will do is basically will drop them. And since they are not in the executable, if there is a vulnerability on one of them, you will not be effective, right? So they minimize vulnerability, reducing the surface attack. And this is interesting because who's using common slang here? I think everyone should raise their hand because I bet that common slang is a transitive dependency of any of the libraries that you have in your project, right? It's gonna be there for sure, right? And has these handy methods like string utils, capitalize, and whatnot, right? Has more than that, right? But this is a good example. So imagine that you only use that, right? String utils, capitalize. You're bringing not only common slang, but all the transitives, right? For a single method. And GraalVM will drop that. So if there is a single advice that I dare to offer you today, it's not even to use Micronaut. My single advice is that you should strive to reduce the number of dependencies in your application, right? Your life will be much easier, right? Easier upgrades, less vulnerabilities, and you will be happier. And compact packaging, because you have like a single binary, it's everything inside. You can copy to the server and run it, you're done. Now, while GraalVM is supported by all the Java frameworks, the combination of Micronaut and GraalVM is unique because you're going to get the lowest startup time and the smallest memory consumption. Not only with a performance penalty, but with a performance benefit, right? It's going to be faster because GraalVM compiler is absolutely magic. Has a magic level that I'm unable to explain, right? It's beyond my abilities to heal. But this example that I'm telling you, 1 billion row challenge, the top, I think top 4 or top 5 performance solutions were using GraalVM native executable, native image. So why this combination of Micronaut and GraalVM is unique? First of all, because we are collocated our sibling teams inside Oracle Labs, so the collaboration with each other is very, very close. Secondly, because of the design decision that we took for creating Micronaut, right? Since there's no reflection, no proxy generation, integration with GraalVM is straightforward. We were ready for GraalVM since day one. Whilst, like for example, Spring Native took 3 years to get it done, right? This is because, like for example, you can use reflection with GraalVM. It's not that you can't use it, you can. But you need to tell GraalVM in advance that you're going to do that. Or like for example, if you're dynamically loading a class at runtime, you need to tell GraalVM in advance that you're going to do that, so that GraalVM puts that class ahead of time in the image. Otherwise, it's not going to be there. So the way you tell GraalVM those things is with metadata, or essentially a bunch of files, a bunch of JSON files that will give hints to the GraalVM compiler, right? We don't need any of that for Micronaut, but other frameworks did need them, right? The third reason is because of the tooling that is created by Oracle Labs, not only for Visual Studio Code, but also for Maven and Gradle. And here I would like to actually appreciate the collaboration that we have with the Spring team. Is anyone using Spring Native or Spring Boot with GraalVM? No? If you use that, if you use basically the Spring Boot Maven plugin, and you want to generate a native image, that will use GraalVM native build tools, which is maintained by my team, and I'm maintaining the Maven plugin literally myself. And it's the same Maven and Gradle plugin used by both Spring and Micronaut. It's literally the same, right? And we have a joint collaboration because I told you about this metadata. Micronaut doesn't need any metadata, but there's third-party libraries like Netty, Hibernate, etc. that do need metadata, right? Initially, we were having each of us like our different collection of metadata, but at some point we decided to join forces and have a single place where we can have a metadata for third-party libraries. That's called the reachability metadata. And that's thanks to the collaboration we have with VMware and the Spring team. So I told you that Micronaut is the fastest, but don't trust me, trust Matt Rabel. Matt Rabel was a developer advocate at Okta. He used to run a framework comparison. He would take an application that would do, Okta is an authentication service. So it would do like an authentication round trip to Okta, forth and back. And he would compare startup time and memory consumption across the 4 Java frameworks. And Micronaut has been consistently in every comparison the fastest in both JIT and native, and also memory consumption. And I'd like to finish this section with a use case, the use case of Disney+. Disney Plus is using Micronaut and GraalVM to run one of the messaging services they have. The traffic is massive. They deploy it on AWS Lambda, and they made the numbers. And if you have something that is going to start really fast, it will basically take less time in the cloud. And in the cloud, time is money. So they're saving money because of that. So far, so good. Was I too fast? You can ask me any questions after that. So let's switch to the demo. I have here is not an empty application. It's not a real world application either, but it's not a hello world, so it has a few things inside, right? So those are my classes. I have an entity. This entity is coming from JPA, but I'm not using JPA. How is this possible? Because Micronaut data comes with 2 flavors. There is Micronaut data JPA, which is using Hibernate as the implementation, but there is a lighter weight version called Micronaut data JDBC, right? And I think this is the same analogy as Spring data JDBC and Spring data JPA, right? So with Micronaut data JDBC, it's going to be faster, it's going to be much more lightweight, but there's, you will not have all the features of Hibernate. Now, the question is, do you need them? That's a question you need to answer yourself. Maybe you don't, maybe you do. But if you don't, I recommend you to use always the lightweight version. So in this case, this is yet another example where I could use different annotations during compilation, but Micronaut data at the runtime. So I could use Micronaut data annotations, or JPA, or even Spring data annotations, right? That doesn't really matter because we have the ability during compilation to map from those to the Micronaut ones. And this is a record, and then we have the repository. The repository is an interface. We are extending from CRUD repository. You probably have seen this before. Nothing new here. Now for this is for the database part. For the REST part, I am declaring a contract. Sorry. This is a contract where I'm declaring the endpoints of my application, right? And it's a Java interface. So this API has 3 endpoints: list, get, and save. This interface has 2 implementations. One is the server or the controller, right? Before I get to this, let me show you a few other things. If we look at the API, I'm using a DTO, right? Because I want to make, it's probably not needed for this example. It's probably like a bit overkilling. But it's a good example to show how you can create or how to solve this problem of entity to DTO mapping. Is anyone using MapStruct? Right, it's very popular. Is anyone using Lombok here? That's more popular. You can also leave the room because Lombok is absolutely terribly evil. This deserves for like a whole session on it. We can discuss that later during the beers. Because of that, because you know, we want you to have less needs to use Lombok. We're slowly introducing few annotations, like for example, this ad builder is not Lombok's ad builder, but it's Micronaut ad builder, right? So we are wanting to have you reduce yet another dependency, and especially Lombok, which is a bit evil. This builder is much nicer because it will not mutate your existing bytecode, which is what Lombok is doing. So in this case, we have the entity. The entity has like 3 fields, like ID, name, and stadium, and the DTO has like a description which is condensing like name and stadium on the same field. So we need to map from entity to DTO because my repository works with entities. My controller works with DTOs, so we need to map them. And here comes the team mapper. This is yet another built-in solution for bin mapping, right? Or a replacement of MapStruct. So MapStruct is obviously a whole library only for this. It has more features than Micronaut's bin mapping. But for most of the use cases, I think this will be enough. So you have the ability to use custom mappings, custom mapping operations. Like, for example, we are here telling the framework how to map the description field, and this is coming from 2 different fields from the stadium, right? And this is using Micronaut expression language. Micronaut expression language is yet another feature. You probably have heard of Spring Spell expression language, right? Here, Micronaut expression language is compile time, and it's going to be type checked during compilation. So you will get compilation errors here. Even if this is a string for the compiler, and a string can contain anything for the compiler, but remember, we hook into the compiler. So for us, it's not just a string. We will type check that. And so this is the interface. We're going to generate this during compilation, and we have methods to convert from entity to DTO and vice versa. And then, the controller is using repository and mapper to make a, realistically, you'll have like a service layer here, but I thought it was too much for a demo. So forgive me for this terrible code. But the actual control implementation is similar to what you do in Spring. So depending on the return type, we will figure out what to do. So you can return a POJO or an HTTP response of a POJO, or you can return a flags or a mono of a POJO, an optional, and depending on that, we will figure out what to do with it. Now, the other side of the contract is the client. So let me take you to the test. So So how do I test this? There's two options. I could, this is a controller, so I could, for example, use WireMock. Is anyone using WireMock for Spring MVC testing? Yes, that's one option. Another option is to use mock MVC from Spring. Anyone using mock MVC? Yeah, and anyone doing like a real functional test with no mocking whatsoever? Is anyone doing that? That's the developer experience. So ideally, what I'd like to do is run my application, grab a high-level HTTP client, because I don't want to deal with a REST template or a REST client, and I don't want to deal with exchange method. I don't want to send any string to the server or parse any response. I want to work with DTOs, right? And this is literally what my team client is. So how do I get a client for my controller? Is one line. It's literally one line. With one line, I get for free a high-level HTTP client for my application. And it's implementing the contract and is using the strongest way to enforce a contract, which is a Java interface, right? So both the server and the client are implementing the same methods. You follow my point? Yeah? So what do we have here? We have Micronaut Test. Micronaut Test will run your application on a random port and will make this class part of the application context so that you can inject any Vim, makes calls to it, right? In this case, this could be considered end-to-end test because I'm testing the application from the outside, right? I'm not, I could be testing, like, for example, the repository that would be inside the application. But in this case, I'm testing the application from the outside, right? And so, like you see, I'm using DTOs in this class, in this test, and it works. Let me run this. I've been praying to the demo gods all day, so I hope they are with me. So we see a few things in here. Well, this is finishes 5.8 seconds, including the whole Maven build, and it is a fully end-to-end test. No mocking whatsoever. Who's using mocking? Who's using Mockito? Who likes mocking? Right? So we use it normally because it is expensive to write such things, right? But I mean, obviously, mocking is still fine. You can still write unit tests, right? Don't get me wrong. You can still write unit tests for this particular method of a class that you're doing something specifically. But for testing a REST API functionally, yeah, you don't have to, right? Just start it and test it, right? And this is the real thing. So we are having Postgres container being started. There is a SQL query, right? I've purposely added this login for those classes because I'm sure you will say that I was doing some trick. I'm not doing any trick. This is the JSON response of my endpoint, so it's all working, right? Normally, you don't test your application like this while you are developing your test. What you do instead is start test resources service. And I have a separate session on how we operate test containers and test resources, but it doesn't fit in here. But let me show you the result of this. The result of this is that I can run my test from the IDE, and it's taking 200 milliseconds, right? 200 milliseconds to start the application, create a connection pool. Obviously, container startup is not included here. Container startup is outside of it. But we will keep the container running for a while so I can run it again. It's instant, right? It's instant. So we think that this is the developer experience that you guys should be having today in year 2024. And the final trick of the show, because I'm running out of time, is to run this on native mode, right? So in this case, Docker context, I want to use TCD, which is Testcontainers desktop. I have here one container. Why? Because I need to stop test resources service. Well, I don't care about Ryuk, so I will start a Postgres container here. This start dv script. It's only doing like a Docker run of a Postgres container. And then I already have generated the native executable before. And I'm activating one environment here. So if I do start native, oh, yes, because I need to use orb stack. And you need to use, I need to tell to use orb stack here. And Docker context, use orb stack. Okay, we have the container in there. And start native. Let me do it again, because if you blink your eyes, you will miss it. And I'm not kidding, because blinking is 300 milliseconds for the human eye, and this is 42 milliseconds. Come on, this is really good, I think. And 42 milliseconds is including creating a connection pool and creating the schema, inserting data, etc. Right? Just to wrap it up, this is my Twitter handle, or X, or whatever you want to call it if you want to reach out. Did you learn something new today? Did you have fun? Yes. Muito obrigado. Thank you very much. Can you display my slides for a moment again, please? So there is a QR code with a very simple feedback form, which I'll be eternally grateful with you if you can provide me some feedback. You can also have links to my social media in there. And in the meantime, do you have any question? No questions. It was everything clear. One question there.
You said if you include necessary kind of reflection for whatever reason.
Yes.
You said it's possible to configure Micronaut to do that. And what is the overhead, let's say, to Micronaut to use for whatever reason?
Right. So the question is, if I need to use reflection for whatever reason, can I do that, and how? And like, for example, you can use Hibernate Validator or Jackson with Micronaut. It's okay. It's not like we kind of forbid the use of reflection. You can use it, but it will ruin those numbers.
Okay, but my point is, it will still make sense to stick with Micronaut.
Yes. 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 Any other question? I will be around for the rest of the day during the beers as well, so feel free to reach out, and otherwise enjoy the rest of the conference, and muito obrigado.